Okay, illustrative math, unit 4, lesson 1 is called growing and shrinking. All right, so our goal today is I understand how to calculate values that are changing exponentially. Okay, exponentially. So you might remember earlier when we had geometric sequences, they ended up getting these like growth or these decay functions. Um, these are actually called exponential functions as well. They come from a geometric sequence, which is multiplying, which is kind of the same as when your variable is in the exponent. So, warm up. A bank account has a balance of $120 on January 1st. Describe a situation in which the account balance for each month, February 1st, March 1st, and so on, forms the following sequences. Write the first three terms of each sequence. Okay, so an arithmetic sequence. So that would be something, something along the lines of you're adding or subtracting the same amount every month. So I'm going to just say, I'm going to say that you deposit, let's say $20 each month. So you're just adding the same amount. So you're going to start out with 120 for the first term, add 20, it'd be 140, 160, and so forth. Okay. A geometric sequence would be something like you're earning, I don't know, let's say 4% interest. Now, I don't want to say interest, earning 4% each month. Okay. Well, interest technically 4% interest. 4% would be your annual interest rate. So we'll just say we're earning 4% each month. Okay, so you're going to start out with 120, and then we got to times that by 1.04. Don't times it by 0.04. Well, you could times it by 0.04, but then you got to add it on to the 120 because you're putting it into the account with the original amount. So I think it's easier just to times it by 1.04, and I get 124.8. And then I'm going to times that by 1.04. And I'm going to get 129.79. I'm going to round to two decimal places because it's money. So again, now that I can write here, I'm done typing. You could do two things. You could do 120 times 1.04, and that'll get me there. Or you could do 120 times 0.04, and that's going to give you the 24.8, but you got to add that back onto the original amount. All right. So, passport photos. So if I want to take a photo and shrink it, you have to make sure that it stays proportional so that your head looks the same. What you don't want is you don't want to get it distorted like that. Okay, we don't want the photo to be too stretched out or something like along those lines. So, we have to make a scaled image. We have to change both sides of the picture proportionally. So, the distance from Elena's chin to the top of her head is 150 millimeters in an image. For U.S. passport photo, this measurement needs to be between 25 and 35 millimeters. Find the height of the image after it's been scaled by 80% the following number of times. Explain or show your reasoning. So you're going to start out with 150. And we're scaling it by 80%, so we're going to times it by 0.80. So what do I get for the next term? 150 times 0.8 gives me 120. So that's my first scale. So it's actually going to be the fourth term because this 150 is not scaled. All right. This is the first scale, the first time I multiplied it by 0.8 times 0.8. Maybe I'll put the times sign like that. So 120 times 0.8, that gives me 96. So that's the second scale times 0.8. And that gives me 76.8. So that's my 3 times I scaled it. It's actually the fourth term of there. So there you go. Now 6 times, well, this was 3, so I got to start at 76.8, and I got to times it by 0.80. I get 61.44 times 0.80 gives me 49.152. And then my last one, end up with 39 point, I'm just going to round it, 32. So how many times would the image need to be scaled? So I think I probably need to do one more. Gets me to 31.46, we'll say. So that gets me less than 35. So I had to do it. How many times did I do it? I did it 1, 2, 3, 4, 5, 6, 7 times. Now, what you could do here is, because you keep multiplying by 0.80 repeated, what you could do is you could take this 150 times it by, times it by 0.8 or 0.80, I should say, to the 7th, because it's kind of the same thing. It's like I'm saying, oh, 0.8, 0.8, 0.8, 7 times. So if I type this into my calculator, I should get the same number here. So why don't you try it if you don't believe me? 150 times 0.80 or 0.8 to the 7th should get the same exact number, which is kind of cool. Shortcut, much easier to just take it to a power than to write it out a bunch of times. So how many times would it need to be scaled by 80% to be less than 25? So knowing that shortcut that I just gave you, I'm going to just maybe plug in some numbers. If I plug in 8, does it become less than 25? Let's try it. 150 times 0.8 to the 8th. It's not, it's 25.17. So it's still not, it's close, but it's not small enough. So I'm going to change it here to a 9. And I'm going to see what that does. Obviously, it's probably going to work. And I get 20.1. So 9 times there. All right. All right. On May 12th, a fast growing species of algae is accidentally introduced to a pond in an urban park. The area of the pond that the algae covers doubles each day. If not controlled, the algae will cover the entire surface of the pond, depriving the fish in the pond of oxygen. At the rate it is growing, this will happen on May 24th, on which day is the pond halfway covered. So a lot of people think it's like halfway through. Everybody, when I teach this lesson in my classroom, a lot of students say, oh, halfway to May 24th would be like May, would that be May 18th? But that is wrong. So do not say May 18th. I'm going to write it down and I'm going to cross it off. That is not right. Okay. That is wrong. Now, if it was linear, like if it was going up in a straight line, it would. But I want you to think about this here. If you're doubling it, so if on May 24th, it's fully covered, that means the day before, can't spell apparently. That means the day before would be half, because if you double 1/2, you get 1. So really, it's May 23rd would be the answer. Okay, so let's think about it. Let's say it's, I don't know, let's say it's 1,000 square meters. Okay, so this would be 1,000, right? Well, if I'm going to double every month or every day, this would have to be half of it the day before. So, kind of makes sense when you think it through. It's kind of a trick question. On May 18th, Claire visits the park. A park caretaker mentions to her that the pond will be completely covered in less than a week. Claire thinks that the caretaker must be mistaken. Why might she find the caretaker's claim hard to believe? Um, well, because on May 18th, you're nowhere, you're not even, you're very less than, much less than half covered. Um, because you don't get to half until May 23rd. So again, I just made up this number 1,000. So let's think here. On May 24th, we're at 1,000. On the 23rd, we'd be at 500. I'm just going to kind of go backwards. On the 22nd, it's 250. The 21st would be like 125. The 20th would be half of 125. So that's like 62.5. The 19th is half of that. And on the 18th, it's a really tiny amount. It's only like 15.625 square meters. And again, I just made these numbers up just to illustrate it, but it's such a small amount out of the full portion of the pond. There's 1,000 square meters and it's only got barely 15 square meters covered. It would definitely be deceiving, but that's how exponential functions work. They go like this and then they shoot up. What fraction of the area of the pond was covered by the algae initially on May 12th? Explain or show your reasoning. So, what fraction on May 12th? So, let's see here. Okay, so this one's a little tricky here. If you wanted to, you could kind of keep going like we did here with this example. If you want to keep going back until you get to May 12th, and then take that number, divide by 1,000, that would work. Um, what I'm going to do though is I'm going to do it a little bit differently here. I'm going to say, okay, you're going to times it by 12 times. We want it to equal eventually 1. So we need some number times 2 to the 12th to equal 1. Why times the 12th? Well, because every month here you times it by 2, right? You just keep going. And if we start, I don't have to write it all out, but if you start on May 12th and then on the 24th, it's 12 times there that you're doing it. So you're doubling 12 times. So this would have to be really 1 over 2 to the 12th to get them to, because then these cancel out and it's just equal to 1. So whatever 1 over 2 to the 12th would be, that would be your answer. So 2 to the 12th is 496. So 4,096. So that would be your answer there. All right, kind of crazy how you had to kind of work backwards there on that one. All right, how are the shrinking passport photo and the growing algae situation similar? I would say we are multiplying by a value. They both form geometric sequences. I would also say that they can be written as exponential functions. Okay, like if For example, the passport photo, I think you start out at 150. So you could say 150 times 0.8 to the x is my f of x. The algae one, your initial amount was 4,096 times 2 to the x. Make that equal to, use g of x there. Okay, so they're exponential. Obviously, this is less than 1, so it ends up being a decay. This is greater than 1, so it ends up growing. How are they different? Well, I kind of answered that right there. Passport is shrinking and the algae is growing. They're growing at different rates. I'd say the algae is growing at a very fast rate while the passport is not shrinking quite as fast. All right, there's a bunch of other different things you could say as well, but those are just some of them. All right, so I did want to add this in here because this is something that always causes problems. This isn't really in your book, so if you want to stop the video, you can. If you want to keep watching, this is just something that we need to make sure that we cover. Percent increase, you add it to 100%. Percent decrease, you subtract from 100%. So if I have an 8% increase, I want to make sure you understand we're going to multiply by 1.08 for an 8% increase. Now, if it's an 8% decrease, because it's really 100% plus 8% gives me 108%, which is 1.08. 8% decrease, kind of the same idea, 100% minus 8% gives me 92%. So we're going to multiply by 0.92. Okay, so make sure you understand that. A lot of people want to multiply by 0.08, but that's not correct. So, town has a population of 13,000, and it grows by 2.5% every year. What will be the population after 5 years? So, well, we're going to multiply by 1.025, and instead of doing it 5 times, like I could write, times 1.025, and I could keep on doing that 5 times. I'm going to shortcut it here, and I'm going to just take it to the 5th, and I'm going to get my answer. So I end up with 14,708. That was to the nearest whole number. Okay. New car is purchased for $23,700. It depreciates at 13.5. So you got to do 100 minus 13.5 and I get 86.5. So I'm going to times it by 0.865. What will the value of the car be to the nearest cent after 10 years? I got to multiply it 10 times. So 23700 times 0.865 to the 10th. That gives me $5,557.88. Okay, cars depreciate. A lot of people are kind of blown away when they see how much their car goes down in value, but that's because it's doing this type of shape, and in the initial part it goes down really quick. All right, $7,900. Place an account with an annual interest rate of 5.5%. How much will be in the account after 11 years? So I got to add this to 1. So it's 1.055 to the 11th. I don't need to multiply it out 11 times. Take the shortcut. And I get 14,236 to the nearest cent. So it's going to be 0.53. All right. All right, so our goal, I understand how to calculate values that are changing exponentially. I think we're in pretty good shape on that. So last thing here for our cool down. Han has a thin rectangular sheet of paper. Its area is 450 square inches. He folds it into thirds and then folds the resulting rectangle into thirds again. So in this one, you're folding it into thirds. You're not decreasing. You don't see the word decreases by 1/3. If it said it decreased by 1/3, you'd be keeping 2/3. So you have to multiply by 2/3. But in this case, it's almost like he's taking a sheet of paper here. Here's my sheet of paper, and let's just say he folds it. Oops, I want an arrow there. Folds it into thirds, and hopefully, yeah, not too bad. I just kind of guesstimated it, but folds it into thirds, so he's only going to be having 1/3 left here. So I'll just use a highlighter here. So this is all that's going to be left because these sides get folded. These sides this folds down to here and then down to there. This part's going to be gone. So we're really times it by 1/3. So let's see here. So this is obviously not going to be correct for the first one. It says Han believes that after 2 rounds of folding, the visible area of the fold paper will be 150 square inches or 1/3 of the original. Well, obviously, if you fold it one time, you're going to be down to 150. Okay, so this is wrong. I would say I don't agree. One fold takes the area to 150 square inches. All right, what's the visible area of the paper in square inches after 4 rounds of folding? So I'm gonna, instead of times it by 1/3 4 times, I'm just gonna times it by 1/3 to the fourth. Little shortcut there. 450 times 1/3 to the fourth, and I get 5.56 square inches. So not much left. All right. All right, so that's it for this lesson. Hopefully you enjoyed it, and thank you for watching.